So this is a brief structure of my talk. So firstly we have introduction and then a discussion of the Exodus software architecture, followed by a description of the two new functionalities in building Exodus, namely the continuous and the course components. And then we shall look at how these new functionalities have been integrated into a new approach which we call the hybrid spatial discretization, also HSD. And then we shall look at the application of the HSD to a demonstration case, followed by some results, conclusions, and future works. Current evacuation and circulation models need a way of representing the space in which the agents navigate. And the current models use one of the three approaches of representing space. These are namely the fine node, the coarse node, and the continuous regions. Now, each of those approaches have its benefits and limitations, with each approach representing a compromise between accuracy and performance. Now, if we were to combine the benefits of each of those approaches into one integrated model, there are certain applications which would definitely benefit from such a mixed approach. For instance, very large complex geometries such as airport terminals and high-rise buildings. And it's this very requirement which has led to the development of a hybrid version of Building Exodus, which utilizes all three approaches together. Next, we shall look at Exodus software architecture, which is the platform in which the new functionalities have been integrated. So Exodus is a set of software tools used to simulate behavior and movement in large complex spaces. It also features a new plugin architecture, which allows new functionalities and components to be integrated into a model using a component-oriented approach. And Exodus is made up of 6 sub-models, namely occupant, movement, behavior, toxicity, hazard, and enclosure. And that plugin architecture is based on the existing layer of the movement and behavioral sub-models. And the two new functionalities which have been developed are the continuous plugins and the coarse plugin, which we shall look at in more detail. So firstly we have the continuous region component. The continuous component allows the simulation of movement of behavior of autonomous agents in continuous space. And the space can be represented by polygons of any shape, and the agents can be placed anywhere in the geometry and will have a unique location. Also, the agents in continuous space have more behavior and attributes which are not present in other node types, for instance acceleration, body width, turning rate, and overtaking strategies. In the continuous component, each agent is modeled as an autonomous character which has adaptive behavior. In other words, the character is able to improvise actions and navigate in the space in a lifelike manner. Also, the autonomy of the continuous agent is defined as a three-layered structure, as we can see here. So we have perception, in which the agent uses a series of sensors to detect goals, for instance exits, also to locate obstacles and other agents. This sensory information is fed into the behavior selection, which controls all the decision-making processes. And the output of the behavior selection is fed into the locomotion, which controls the articulation, that is, the actual movement of the agent. It also helps to maintain the agent in a valid state, that is, to prevent the agents from overlapping each other and from overlapping obstacles. Behaviors in the continuous model are developed as components, and these can be tested individually, followed by an incremental integration. And these behaviors serve as building blocks for constructing more complex behavioral routines. And examples of movement behaviors in Building Exodus include seek. This involves identifying the waypoint, and they move the agents towards the waypoint, adjusting the speed and orientation. Next we have agent avoidance. The agents use a perception box to locate agents in its vicinity and it can also differentiate between agents moving in contraflows and unidirections. And the agent adjusts the travel speed and orientation to avoid collisions. Next we have wall avoidance, in which the agent uses a line of sight check for walls and waypoints and avoid the walls if it's in the current path. Next we have queuing, which is a combination of seek and agent avoidance, coupled with a waiting attribute which is triggered when the agents fall within the personal space of the assessing agent. The agents in the continuous component also demonstrate emergent lane formation due to the fact that the avoidance criteria for agents moving in contour flows is higher than those moving in unidirections. In other words, agents tend to follow a path of least resistance, which is often seen in crowds. A key data structure in the continuous component is its navigational graph. This graph is a network of waypoints and path segments used by the agent. And this graph is automatically generated when a continuous polygon is converted into a continuous space. Also, the location of those waypoints drive the agents away from the location of the walls, and this significantly reduces the collision detection checks by the agents, therefore improving computational performance. Next, we shall look at the second functionality which we've implemented, called the coarse network component. In this component, the available physical space is segmented into partitions, whereby each partition can represent a particular section of a geometry, such as a room or a corridor. Also, the agents in the coarse network component move from segment to segment, such that the exact physical location is now represented. Also, the flow rate of the agents in the coarse node is a function of travel speed, travel distance, and population density. The flow rate is dictated by a movement function which makes use of different parameters to cater for different types of coarse nodes implemented in Building Exodus. And these are namely the compartment, intersection, interchange, gates, stairs, escalators, and travelators. The nature of the coarse nodes restricts the modeling of geometries using simple geometrical shapes such as squares and rectangles. However, this might not be sufficient for modeling all the complexities and intricacies of a building. In Building Exodus, there's a novel feature which allows the creation and the use of non-convex coarse nodes. And such coarse nodes can provide a closer representation of the geometry. And the key data structure behind the advanced coarse node is a mesh which is based on the same principle as the navigational graph used in the continuous component. The coarse node component features a behavioral mechanism which allows agents to adjust their path depending on evolving population density conditions in the node. This is achieved by a load balancing algorithm which dynamically adjusts the potential value of waypoints to account for the number of agents heading towards them. For instance, in the diagram here we have a coarse node with 3 routes, namely A1 to A3. Without the application of this algorithm, all the agents would be seen to enter at waypoint P0 and leave waypoint P2. Whereby when this algorithm is applied, the agents would be seen to use paths A1 to A3 more evenly, therefore minimizing the dwell time spent due to congestion in the coarse node.